Hello everyone, welcome you all to the microcontroller class. Today we will be having session 5 of unit 3 embedded C, and these are the contents of today's discussion: code conversion in C as well as some of the simple programs. Coming to the code conversion in C, consider the following three main data formats like ASCII, binary and unpacked BCD as shown in the table. So these are the commonly used formats to represent the numbers like ASCII American Standard Code for information interchange, as well as the binary representation of the hexadecimal number, as well as the BCD representation of a given number. These three are commonly used in microcontrollers and microprocessors for performing various operations in real time. Logic and shift operators can be used to provide the data conversion from one format to another format. So code conversion is required. This is called as code conversion. I want to convert from ASCII to binary, or binary to BCD, BCD to ASCII, BCD to binary, or ASCII to BCD. So these conversions are called as code conversion. So these code conversions are required for in some of the applications, and that can be performed by writing program in the microcontroller. So first of all, we shall see that these are the actual numbers that were represented. We call this as a key. From 0 to 9 we have represented. And what is the ASCII value of these numbers? For any given number, if I want to find its ASCII number, add 30 to it. If I add 30 to 0, 30. If I add 1 to 30, it is 31. If I add 30 to 6, 36. So for a given number, if I add 30, then the number will be converted into its ASCII value. And similarly, I can able to do the representation of these ASCII in terms of binary. So how do you represent 3? 3 is nothing but 0, 1, 1. So either I can write 0, 0, 1, 1, that is also 3, or you can write only single 0, 1, 1. Because to represent 3, it requires only 2 bits. Third bit, fourth bit is not required. Or simply I can write only 1, 1. Even if I write 1, 1, it is nothing but 3. So if you add a number of zeros, if nothing is there before this one, then it means that 0 is there. So we can make the length equal to 4 bits by adding 2 zeros here. Therefore, either it is 0, 0, 1, 1 or it is single 0, 1, 1. It represents 3. So this is 3 and this is 0. Similarly, 35 is what? 0, 1, 1, 3 and 5 is 0, 1, 0, 1. Similarly, 39 is 0, 1, 1, 1, 0, 0, 1. And I can represent these numbers, these key numbers, in terms of unpacked BCD. So to represent these numbers in the unpacked BCD, what I will do, I will going to subtract 30 from this, or I will going to subtract 30 from this. So if I subtract 30 from this, then these things will cancel. These things will cancel. So only these things are left. Only these values are left. So I can write it as 0, 0, 0, 0, 0, 1. So anyhow, this will be equal to 0 now. And what is its equivalent value? This is nothing but 0. In hexadecimal, 4 zeros in binary is nothing but 0, and 1 is nothing but 1. So this is unpacked BCD. It is already in unpacked form. Similarly, for 7, it is 0, 1, 1 is 7, and similarly for 9, it is 1, 0, 0, 1. So these are the unpacked BCD number. Now we shall see some of the programs for the code conversion. Write an 8051 C program to convert unpacked BCD number at the location BCD1. So BCD1 is the memory location into ASCII number and display it on port 0. So what is the question now? We need to convert unpacked BCD number into its equivalent ASCII number. It is BCD to ASCII conversion. And we need to, and where the number is stored? The number is stored in the memory location called as BCD. BCD is the memory location. And after conversion, the converted number has to be sent to, or has to be displayed on port 0. So the program is like this: hash include reg51.h. So I will declare unsigned char BCD1, where BCD1 is the memory location. Unsigned char BCD1, and it is a global variable now. So this is a variable. It can be anything, any name you can able to give. Variable of type character, and it is unsigned character. And since it is declared before the main, since this variable is defined before the main, this type of variable is called as global variable. And this global variable can be accessed by any of the functions, including main function. Then I write void main, open brace. Then I will use ACC. ACC is nothing but the accumulator. I will want to use the accumulator register, which is equal to BCD1. What I will do, I will take this memory location. From the memory location, I will copy the number into accumulator register. Then I will do OR operation with 30. For example, let us assume that the number BCD1 in the memory location BCD1, this is memory location. For the memory location, some name is given. We shall assume that this BCD1 memory location contains the number 04. 04 is the number that is present in the BCD1 memory location. So now what I will do, I will take that 4 into the accumulator. Now accumulator contains the number 4. Now 4 OR with 30. So 4 is nothing but 04. That has to be ORed with 34. We are having 30 and then we are having 04 in hexadecimal. So if you OR 0 with 4, the same number you are going to get, and again 0 with any number, the same number you are going to get. Therefore 34 is the answer. So actually you have to do by converting it into binary. What is the binary equivalent of 3? That is nothing but 0011. And what is the binary equivalent of 0? That is nothing but 0000. And similarly, what is 04 in terms of binary? So it is nothing but 0000, and 4 is 0100. This is 0. Now do the OR operation. We know that in OR gate, when both the inputs are 0, then only the output is 0. Otherwise, the output is 1. So for these cases, the output is 0. Again, convert it to hexadecimal. So this is nothing but 3 and this is nothing but 4, 34. Or directly you can do this. 0 OR with any number, same number you are going to get. Therefore 34 is the answer you are going to get. And this 34 will be again stored back to accumulator. Accumulator contains 30. Accumulator contains 04 and this 30 is nothing but this 30. So when you do the, and we are performing the OR operation. And where the result is stored, the result is stored back to accumulator again. And from the accumulator, that result will be stored to sent to P0, because display it on P0. The question is, after conversion, display it on P0 port 0. Then keep executing this instruction while 1 along with the semicolon. Then the microcontroller, after the execution of this one, it will enter into the infinite loop. So remember, for any number, if I want to convert any BCD number into ASCII number, you have to add 30, or you have to do the OR operation of a given number with the 30. It will, both are one and the same. For example, if I am having the number 9, add 30 to 9. Then what it becomes? It becomes 39. Even if you do the OR operation with 9 and 30, if you do the OR operation between 9 and 30, again you are going to get the 39 as the answer. So this is the method. This is the logic for converting unpacked BCD number into ASCII number. Then the second program is write 8051 C program to convert ASCII number at location ASCII 1 into unpacked BCD. Now reverse we need to do. So ASCII number is stored in the location ASCII 1. So this is the memory location, and the address of this memory location is ASCII 1. ASCII 1 is not actually the address, it is the name given to the address. Address is always some hexadecimal number. For example, the address may be something like 0x1100. This is the address. That is nothing but 1100H. This is the address of the memory location. And for this memory location, I have given the name ASCII 1. ASCII, this is 1. ASCII 1 is the name. And shall assume that some ASCII number is stored here. Shall take the ASCII number stored in this memory location is 32. You know, ASCII number always starts from 30 for the numbers, for numerals from 0 to 9. That 32 is the ASCII number. I want to convert this ASCII number into equivalent unpacked BCD. So what I will do now, unsigned char ASCII 1, this is the global variable, and again void main, accumulator is equal to ASCII 1. Go to this memory location, take this number 32. Now that will be stored into accumulator. Now accumulator becomes 32. Then accumulator is equal to accumulator AND with 0F. What is the content of accumulator? 32 is the content of accumulator, and we need to perform AND operation with 0F. So when you do AND operation of any number with 0, the output is always 0. AND operation of F with any number, the output is the same number. How it is? You convert it to binary and you check and verify. What is 3? 3 is nothing but 0011, and 2 is 0010. Similarly, what is 0? 0 is nothing but 4 zeros in binary, and F is 1111. Now do the AND operation. You know AND gate, when both the inputs are 1, then only the output is 1. Otherwise, the output is 0. So for all other cases, the output is 0. So this is nothing but 0, and this is nothing but 2. Therefore 0 to H is the answer. So if you do AND operation of any number with 0 in hexadecimal, output is 0. AND operation of F with any number is the same number. Therefore 02 is the number, and that 02 is sent to port 0. Therefore ASCII by BCD equivalent, unpacked BCD equivalent of 32 is what? Unpacked BCD of 32 is nothing but 0 to H hexadecimal, and that is sent to P0, port 0. Next, example 3. Write an 8051 C program to convert packed BCD 29 to ASCII and display the bytes on P1 and P2. So what we need to do? C program to convert the packed BCD. Now we were discussing the unpacked BCD. Now they have given packed BCD. 29 is the packed BCD, and it has to be converted into is equivalent ASCII. We know the procedure for converting packed BCD into ASCII. So this packed BCD is initially converted to unpacked BCD. How to do unpacking? So write 02 and 09 separately. So this is called as unpacked BCD. This is called as packing, and this is called as unpacking. Now add 30 to it. Either you do the add operation or you do OR operation. Both will do the same. So this becomes 39 and this becomes 32. Therefore 32 and 39 are the equivalent ASCII codes for the packed BCD number 29. So this procedure we need to follow. So what I will do, void main unsigned char, I will declare two variables x and y. Unsigned char PBCD. PBCD means packed BCD. P stands for packed BCD, which is equal to 0x29. Now the number 0x29 is stored into the variable packed BCD, which is of type character, unsigned character. Then what I will do, x is equal to, now packed PBCD contains 29. I will take the 29, do the AND operation with 0f. So you take 29 and this should be ANDed with 0f. So when you do the AND operation, I told you any number ANDed with 0, the output is 0. Any number ANDed with f, the same number you are going to get. So what do you get? 09 you are going to get. So I want 09 first. Then what I will do, and the result will be stored in the x. So this will be stored in variable x, and that value will be taken, and that is ORed with 30. So 09 ORed with 30. What is the answer you are going to get? 39 is the answer. That 39 is sent to port 1 because they have given. After unpacking, after converting it to ASCII, you send one byte into P1 and another byte into P2. Now this byte 39 is sent to port 1. Similarly, I will take another variable, that is nothing but y. Y is equal to PBCD ANDed with 0xf0 now. What is PBCD? PBCD is nothing but 29. Once again take that number 29. Now do the AND operation. Do the AND operation with f0. 0 with any number, AND operation is 0. 2 with f, AND operation is 20. but I don't want 2 0, I want 0 2. So to convert this into 0 2, I will do the shifting operation. Y is equal to y, right shift 4 times. So when you perform that, you can write it in binary. So that is nothing but 0 0 1 0 is 2, and 0 is 0 0 0 0. You have to do the right shift of this number for how many times? For 4 times. So every time when you do the right shift, you keep add 0 from the left side for every shift. So after 4 shifts, what do you get? Here you are going to get 4 zeros, and these 4 bits will come to this position, because 4 shifting we are going to do. 1 shift, 2nd shift, 3rd shift, and 4th shift. All the bits will come and occupy this position. That is nothing but 0 0 1 0. So this is 0 in hexadecimal, and this is 2 in hexadecimal. Therefore 0 2 is the answer. So when you do y right shift with 4, now these two will be, means this number will be changed to next position. Therefore 20 becomes 0 2. Now do the OR operation with 30. Now you take, and the result will be 0 2 result will be stored in variable y. Take that number, do the OR operation with 30. So 0 to OR with 30 is nothing but 32. And again 32 will be sent to 4 to 2. Therefore 4 to 2 will contain 32 number. That number will be displayed on the 4 to 2. 39 is displayed on P1 and 32 is displayed on P2. So this is how we can convert packed BCD into ASCII code. And example 4. Write an 8051C program to convert ASCII digit 4, that is nothing but 34. ASCII digit of 4 is 34, and 7, that is nothing but 37, to packed BCD and display them on P0. So what is there now? 34 is there and 37 is there. We need to convert it to packed BCD. So we have to separate these two, and then we have to group these two, 4 and 7. So that gives the packed BCD. So we shall see now, and then after you need to display it on the port 0. So void main and unsigned char BCD byte. One variable I will take, BCD byte. Unsigned char x is equal to 4 within single quote, and again unsigned char y is equal to 7 within single quote. When you are going to use this type of statement, actually when any character is enclosed within the single quote, then the ASCII value of this character will be stored in the variable. What is the variable here? X is the variable, and it is of type character, that to unsigned character. So after the execution of this one, what is the content of x now? So x is equal to ASCII value of 4, that is what? 34. So x contains 34. Similarly for this case, we are going to within single quote, therefore y contains 37. So x contains 34 and y contains 37. ASCII value of 7 and the ASCII value of 4 will be stored here. Then I will take that x number, do the AND operation with 0f. What is x? X is equal to 34. So 34 AND with 0f. So what is the answer now? 0 AND with 3 is 0. F AND with 4 is nothing but 4. And this will be stored back to x again. And we are going to do the left shift of this number 4 times. So when you do the left shift of this number 4 times, so 0 4 will become 4 0, because we are doing left shift operation. So you shift all the bits towards left by 1 time, and every time you keep appending 0 from the right side. Appending ಅಂತಂದ್ರೆ add ಮಾಡ್ತಾ ಹೋಗಬೇಕು. add ಅಂದ್ರೆ ಜೋಡಿಸೋದು ಈ ತರ. So this is called as appending. ಒಂದ್ರ ಪಕ್ಕ ಒಂದು ಜೋಡಿಸೋದನ್ನ appending ಅಂತ ಹೇಳ್ತೀವಿ. Next, now x contains 40. Now I will take the number y is equal to 37. Do the AND operation with 0f. So this AND with 0f. 0 AND with anything is 0. F AND with 7 is 7. Now 7 will be stored in variable y. Then what I will do, BCD byte is equal to XOR with y. BCD byte is nothing but this variable. This is declared to store the result, that is equal to X OR with Y. What is X now? X is equal to 40. Do the OR operation with Y. What is Y? Y is 0, 7. Do the OR operation between these two. 0 OR with any number is the same number. Again 0 OR with any number is same number. And this is stored in where? This is stored in BCD byte. And that will be displayed in port 0. Take that BCD byte, which is nothing but 47. 47 is sent to port 0. So we have converted the ASCII now value of 4 and 7 into its equivalent unpacked BCD, and then we have packed them and it is sent to port 0. In summary, in this session we have learned some of the simple code conversions by using C programming and the sample programs for these code conversion. Thank you.